Today I'd like to talk to you a little bit about the cardiovascular system, one of several systems in your body that function in transportation. However, the cardiovascular system is the most important system in terms of carrying things around in your body. We have to talk just a little bit about the components of the cardiovascular system before we can see how it works as a unit. To strip things down, your cardiovascular system contains two primary regions. First region will be your heart, which is an organ about the size of a softball, more or less. It's located in the upper portion of your body called your thoracic cavity. We also, from the heart and to the heart, have a series, miles and miles actually, of tubes that carry blood both away from the heart and then eventually back towards the heart. Your heart has several special properties. First of all, think of its job. It never gets a break, never gets a 15-minute timeout. It beats from development embryologically until death. The heart is the only location in the body where we find cardiac muscle cells. These cells are extremely durable. These cells have incredible endurance, and these cells have a few other special properties. The cells in your heart can act all by themselves. If you leave your heart alone, it will beat on average about 100 times per minute. It can work without any intervention from your brain or your spinal cord. However, we usually try to control it a little more readily because sometimes we sleep and we can shut our heart or slow our heart down a little bit, or sometimes we're in a nasty traffic situation and blood pressure goes up a little bit and things start working a little more rapidly. Our heart is going to have several primary functions. Using this striated or striped, arranged in a very specific fashion, cardiac muscle, your heart will receive blood from body tissues. Your heart will then send blood up to your lungs, where it can fill with a very important molecule called oxygen. Blood will return to the heart, now containing oxygen. And last but not least, your heart has a responsibility of sending this blood that now contains oxygen, the stuff that life is made of for us, out to every single tissue in the body. If you were to look inside the heart, you'd see four small hollow spaces. These hollow spaces are called chambers, and they have several different functions. On the right side of the heart, there are two chambers, a top and a bottom chamber, as there are on the left side of the heart. The right side of the heart specializes in dealing with blood that does not contain oxygen. The left side of the heart specializes in receiving and pumping to the rest of the body good, oxygenated, red, perfect, beautiful blood. In order to operate effectively, we've got to control these chambers. These four separate spaces, controlled and surrounded by cardiac muscle, have to be coordinated. If they did their own thing, we wouldn't be around very long to worry about. There's a small region called the pacemaker that's located to the right side of your heart. The pacemaker is going to be important because although the heart can operate by itself, it's truly the pacemaker, as the name implies, that sets the pace and causes each contraction. Under resting conditions, an average heartbeat might be 80 times per minute, although it can go up to as many as 200 per minute during heavy activity or stress, and it can also drop significantly lower. The pacemaker is a special group of cells that generates a tiny little electrical impulse every so often. We'll say 100 times per minute. When the impulse is generated, your heart becomes excited. First of all, the top half of the heart becomes excited, and then a split second later, the bottom half of the heart becomes excited. By having these hollow chambers that can receive and squeeze blood in different directions, and by regulating them in a specific fashion, we can very effectively take blood into our heart, send it up to our lungs, return oxygenated blood to the heart, and last but not least, send that good oxygenated blood up to the body. In order to carry oxygen to tissues, maybe your big toe, maybe your ear, maybe your eyeball or your pancreas, we're going to use hollow tubes that are surrounded by muscle that we collectively refer to as blood vessels. Now, blood vessels come in a bunch of different varieties. Perhaps you've heard the terms arteries or arterioles or capillaries, or perhaps venules or veins. There are going to be several different types of hollow tubes that carry blood away from your heart down to some region in your body, and there will be several types of tubes that carry blood from that region in your body back to your heart. It's really an incredible loop. Every day, your cardiovascular system, your heart, and your blood vessels function by moving about 2,000 gallons of blood. Now, you don't have 2,000 gallons 2,000 gallons of blood in you. What that 2,000 represents is your internal blood volume recycled many times. It's a wonderful recycling system in our body. Blood flows away from the heart in structures called arteries. Once blood gets to your big toe or your pancreas, oxygen and glucose and sugar and all the nutrients that your big toe needs to survive on a minute-to-minute basis are delivered from arteries. Your big toe, as a result of being alive, produces waste materials that must be removed lest they cause harm. Materials such as carbon dioxide, a waste product, and some other acids that can cause harm are carried from your big toe, for example, back up to the heart through structures known as venules or veins. So we really have two systems. We have an away system from the heart, and we have a towards system from the heart. Using both of these loops and the centralized pump, we can effectively take blood that's deoxygenated and fill it with oxygen using small chemicals. We can send that good blood out to the body, and we can return waste to the heart where they can get gotten rid of by your respiratory system.